Okay, right now we will try to express Coulomb's law in vector form, and let us see what is the importance of expressing Coulomb's law in the vector form. Consider two charges here. Let it be Q1, here is Q2. Let them be separated by R, and if both the charges are assumed to be positive, let F21 be the force exerted on the second charge by the first charge in this direction, and let F12 be the force exerted on the first charge Q1 by the second charge Q2. And in order to find the direction of the two forces, we need to take unit vector r hat, and this unit vector is used just to find the direction only, and the direction should be r12 here. It means in order to find the direction of the force, we will be taking a unit vector from Q1 to Q2, and the direction is here towards the right. Similarly, in order to find the direction of the force towards the left, we need to take another unit vector r hat or r cap, and it is directing from the second charge towards the first charge here. We will write the Coulomb's law here. You can choose any one of the two forces. Let us write the first one here. At the top of this F21, let us write the arrow here, so it's for the vector notation. So F21 vector is equal to 1 divided by 4 pi epsilon naught, and the two charges Q1 Q2 divided by square of the distance, so you have r square. Then between the two unit vectors, you need to choose the unit vector which has the same direction as F21. So clearly R21 is in the direction of F21, so we need to write here R12 hat. So let it be the first equation here, equation number 1. And if we write the second equation here, let us say F12, so it is equal to 1 divided by 4 pi epsilon naught. The two charges are Q1 Q2 divided by r square again, and the unit vector in the direction of F12 is R21 hat. So this is equation number 2. And as per vector algebra, R12 hat, this is equal to minus R21 hat. So you can use this the value of R12 hat here as, and you can substitute here this value in equation number 1. If you substitute here in equation number 1, you can write F21 vector is equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by r square, and in place of in place of R12 hat, you can write minus R21 hat. So this will give you negative here. Let me write negative first, and this is what 1 divided by 4 pi epsilon naught Q1 Q2 divided by r square, and R21 here, R21 hat, exactly the same as equation number 2. So I write this negative sign here, and the rest, this term, I substitute this F12 vector here. So this is Newton's third law of motion. The expression of Coulomb's force or Coulomb's law in the vector form can be represented either by equation number 1 or equation number 2. You can use any one of the two equations, 1 or 2, to represent Coulomb's law in the vector form. The importance of writing Coulomb's law in the vector form is that when you write in this expression, you can prove that Coulomb's law obeys the third law of motion. To show that Coulomb's law, it obeys the third law of motion.